Okay, so for this first one, what do we do? Set the exponents equal to each other. On the base of the same, you can just drop them and set the exponents equal to each other. How do I solve this? To get a, and then, so x equals, good stuff, negative 1/4. What about the next one? Yep, you can make 81 to 3 to a certain exponent. What exponent? 4. Okay? So even if you have an equation, exponential equation, where you have a base of 3, but then it equals a number, see if you can write it to have the same basis. So then we can do the same thing we did in the first one and just set the exponents equal to each other. How do I solve this? Subtract 1 and x to get what? And then and x equals good stuff. What about that last one though? I can't write 24 as 3 to or anything like that. Or how do I do that?
You move the x to the bottom.
Move the x to the bottom? Like moving the x to the bottom would then change the exponent to be positive. That might make it just a tad bit difficult to work with. Other ideas? You can divide by 3. Because that 3 is being multiplied to that x, isn't it? So you have x to negative 3/5 equals 8. We're not going to use log here. No calculator. Still in the no calculator section. How I think about it, how can I get rid of that exponent? You can multiply the exponent by the reciprocal. That's another way you can do it. Okay, so we don't have to worry about logs or anything like that, okay? If you multiply this by 5/3, and let's make this a negative 5/3, so that way it turns positive. You do that to both sides. Okay? So then our exponents on the left cancel each other out. And then I have 8 to negative 5/3. How do I simplify that?
8 to the third power.
8 to the third power?
Or no, 8 to the negative fifth power in Hebrew.
Okay. So back to this. Okay, I heard flip. Flip it, turn it positive. I heard something about a cube root. Okay. So you want me to write this as a radical? Okay. Cube root, 8 to the 5th. Still not calculator. Is 8 to the 2nd.
And 64 times 8.
And then that number times 8. And that number times 8. Someone else? How else do we know? What other way can we write 8? 2 to the 3rd. If I were to rewrite 8 as 2 to the 3rd, you know, I'm still multiplying it by, or still raising it to a negative 5/3. What do you notice? What do you do here?
Oh,
It cancels. What gets canceled?
the 3.
The 3. So when I multiply, this basically becomes negative 15 over 3, which is negative 5. And this is a little bit easier to do, right? What's 2 to the negative 5th power? So don't forget about that. Okay? All these different ways to solve an exponential equation without using your calculator. Okay? Based on the same, they cancel, so they're going to equal to each other, and also you can multiply by the reciprocal of the exponents. Reviewing exponential functions. Let's start with the form. How do you know you're dealing with the exponential function over something else? Okay, so what is like the general form? Y equals what? Like I know y equals ax squared plus bx plus c is a quadratic. Y equals ax plus b is linear. That's one specific. I want a general exponential. A to the x, or b to the x, either one. But A represents your base, but your exponent is your variable. Okay, that's the general form for exponential function. E to the x is a specific exponential function. Okay, that one's a specific exponential function. And what does this look like? What does it look like? Careful. So that one thing is a what kind of function? It's a radical function, but exponential goes. Okay, so the exponential function is, what's the domain of the exponential function? Yes, negative infinity to infinity. There are no restrictions along the x's, so what about your range? 0 to infinity. My question is 0 included?
No.
Yes, there's an asymptote at the x-axis, so no, 0 is not included. Just everything higher than 0. This is your most basic exponential function. There are two types of exponential functions, known as exponential blank and exponential blank. And yes, growth and decay. Two different types. The one right here that's drawn on the board, that's an example of exponential, and decay would be the other way. Okay, basically a decline. X-intercepts. What are they?
Are there none?
Why are there none?
Because 0 is the asymptote and 0 is the x-axis.
There you go. There are no x-intercepts. Is there a y-intercept? Where? It's a point. All intercepts are a point, so 0, 1. And your end behavior. As x approaches infinity, y approaches what? Look at this.
Y approaches
Y approaches infinity. Just keep going up, up, up. Okay? And as x approaches negative infinity, y approaches what? Okay? These are your properties and features of your exponential functions, the graph. Do not forget that the transformation rules apply also when you're graphing, okay? By transformations, I mean a translation to the left or to the right, up or down, a reflection over your x-axis or your y-axis, and a dilation of the horizontal or vertical stretch or shrink. Do not forget about those, okay? Do not forget about those. And if you're ever wondering, you know, if you had to graph this without a calculator, you could use that y-intercept as a reference point, okay? Anything else beyond that to move it as necessary. Yes?
What does the exponential function look like when you're moving it? Like you do with the quadratics, where you like add 1 to make it go over 1, or like subtract 1 to make it go by 1?
Good question. Okay, say you had this function right here, okay? That's your parent function. And then you had this type of transformation. This up here, when it's up in the exponent, means to move what? Left or right? Horizontally. So which way? Left, because it's always the opposite. And this minus 2 is not in the exponent, would go down. Okay? And if I'm flip, what if I put a negative here? Flips it over the
I'm gonna say that's going to flip over your x because it makes the y negative.
It is over the x because it makes your y is negative. Now, if the negative had been in the exponent, then I'm making my x is negative, which is flipping it over the y. So do not forget, all those rules will apply.
If you're stretching it, will it just go into the 2?
It would, they could very well do something like this to let you know there.
So that means stretching it by 1/3.
They might put it on the inside as well and then do the multiplication dot or binary x. Oh, this, yes. I'll confuse how that. Right.
So it started off with a huge x.
Correct.
So if it was a vertical stretch of 1/2 or so would they ever multiply that by the 2?
No. They would show it separate. A horizontal one would be if the 1/2 was up in the exponent with the x. Okay, that's how you know the difference between vertical and horizontal. Good question. All good questions. This is to refresh your memory here, okay? Just to refresh your memory. Properties of logarithms, okay? If b equals a to the x, then log base a of b is equal to x, okay? Logarithms are exponential functions inverse, okay? So remember, you can always go from exponential to logarithmic form and vice versa. Just remember some of these properties. Okay. Okay, here we go. Log base a of a equals what? Say again. It is 1. Log base a of 1 is, say again, 0. Yes. And if you're wondering, how are you getting that? Think about it. You can always rewrite a log as an exponential, okay? The base would be a. The exponent would be what it equals. That's what we're trying to find out. And it equals b. So it would have to be 1. Okay? This is a to the first power. Same thing here. It'll be a. So what gives me 0? Only thing that can ever give you, equal 1. Only thing that can ever give you 1 is 0. Log base a of b is undefined when b is negative. You cannot take the log of a negative number. So b always has to be positive. Log base a of 0 is, that would be log base a of 1. Doesn't exist, so that means it's undefined. Because remember, b cannot be negative, it has to be positive. It can't be 0 either. Okay? There's no number that you can ever raise a to that's going to give you 0. Lastly, log base a of a to the n equals n. Okay? Basically, it applies up here. All right, so we can just go ahead and look with the x on it. Okay? So, applying all that, your logarithm. Wait, hold on. Is that in my next thing? A second. Okay, never mind. I'll do it there. All right. Properties of logarithms. Do not forget about those. Are these in your reference booklet? I don't think so. I know your laws of exponents are, but I don't think these are. Somebody might want to check that to confirm, but I'm going to go with no, and I'm like 70% sure. So no. All right? Let's evaluate these. Okay? Log base 64 to the 4th. No, log base 64 of 4. What would that mean? Or how could I evaluate this? I'm still in the non-calculator part of everything.
You set up like 4 to x
So it's 4 to the x equals 64? Careful.
That's not a thing.
64.
It's 64
Oh.
to the x equals 4. Okay? How do I solve this?
Just X.
Just do it now.
Big 4.
Last time I checked, it
Is it
would be
1/3?
So 4 to the what?
I said 64.
64 to the 1/3. You think?
factor out.
So,
Yeah.
so,
Factor out. We gotta factor out 4x.
I
We gotta make
okay
it-
with that.
So, Sydney's right, it would be 1/3.
It would go how? How you doing 30?
Because
Because 4 to the 3rd is 64, yes. That is true. You can also go, when 4 to the 3rd, there's an x. You can also do it that way. Set your exponents equal to each other. So yeah, x would be 1/3. Don't forget about that. You can also use that here. Okay? What about this one? Log of 5 with the base of 5 of 1. You said 5 to x equals 1? So x will equal 0. The only way that we can ever get 1 is if the exponent is 0. Yes. What about this one? Log base 2 of 2 to the 5th. Equals 5. That was that last one. You have the base. Same. What about this one? X equals 2 to the 5th power. Exactly. So x is what?
32.
Okay. Use your properties to help you evaluate some of your logs. Okay. Don't forget about these. That's how you apply them. Okay. Questions? If you ever forget, you can always convert to exponential form and then kind of go from there to help you solve. Questions? Questions? Questions?
Can you give me 2 more seconds for answers?
I sure can. Moving forward. Like I already said, exponentials and logs are inverses of each other. So what we're going to do is we're going to find the inverse of y equals 2 to the x. And we're going to do that algebraically as a nice little review of functions. Okay? I do also from y here. Take the log of both sides. Okay? Your y will come in front. No, no one will cancel out there.
So it would become log 1 power out of log
Wait, I think y'all said the same thing. What'd you say?
I said, would it be log use the power tax?
I mean, like 2 is the base and then x is on the same line with the log? Yes. It should look familiar. I mean, it's kind of going a little bit forward than what I'm going to get there eventually, but this should look familiar. What's this look like? Like how? Like what was that thing called that would allow you to combine these two together to get log change of base? Y'all remember change of base formula? Wait, we're going to get there. It was like at the end of this, but yeah. Okay. Another way that you could have done it, when you took the log of both sides, you could have actually took the log of the base so that they would cancel each other out. I mean, it's the same thing. 2 is the base. It's a normal x. Yeah.
Yeah, but I say, that's what I was doing at the beginning.
So this part?
Yeah, just writing it different.
No, you took the log of the same base so that they would cancel out, but then you just did that one of those properties. You do that. So, keep going. Properties of the graphs of logarithms, okay? We're looking at the graph now. We talked a little bit about it already, I think. Just a little bit. What's the domain of a logarithm? It is 0 to infinity. Is 0 included? No, it's not. What's the range? Negative infinity to infinity. What about my y-intercept? How do you know it's numbered? Everything's flipped. Exactly. Logarithms and exponentials, they're inverses of each other. That's why the domain of a logarithmic function is the range of an exponential. The range of a log is the domain of the exponential. We have no y-intercepts. What are our x-intercepts? Not 0, 1, 1, 0. And what about our end behavior? As x approaches infinity, y approaches, got it, infinity. And as, well, I guess it really could be what's happening as x approaches 0? What is y approaching? Negative infinity. Yes. So, there's basically an asymptote right there on your y-axis. It crosses the x at 0, 1. As it approaches 0, y approaches infinity. The other shoots off that way. They're inverses, so basically you reflect over the line of y equals x of your exponential function. Okay? This would have been your exponential function here. So you reflect over that line. A-S-Y-N, asymptote. A-S-Y-M-P-T-O-T-E, asymptote. Translations apply as well with this one, okay? Every log is set up as such. The base could be any type of number, okay? Say we just have this generic parent function of log base 2x. If I have negative log base 2 of x minus 3 plus 1, what does that negative mean in the front? Flipped over the x-axis. That minus 3 on the inside means right 3, and then the plus 1 means of 1. So the same transformations apply. Same transformations apply. A few more things that you need to know, like extra additional information. It's pretty self-explanatory. Yes? Okay, certain things you need to remember. I remember ln and e, they cancel each other out. When you take e and raise it to the ln, they cancel out. Okay? The calculator, on the calculator, the log button, Yeah, as a base of what? A base of 10. Very good. Yes, got that. Yes.
You gotta like change the base.
You can't that, but not for that log button. That's why the change of base formula is there, so you can evaluate things such as the log of 9 of 3. Scientific one. Oh yes, those do have like you press something, you can type in your own base in your own. Solve this. This is how I'll do this. I'll do 2 with you guys. You do 2 on your own. Which 2 do you want me to do with you?
Hold on, let's look.
Okay. Say it. No, it'll only be 2. So 3 and 4. Okay, we're going to solve this around the 3 significant figures. Okay, so we will be using our calculators for this. To solve, here you have 10 to the x equals 0.0 or 0.75. To solve, to get x out of the exponent, you have to take the log of both sides. And when you take the log of both sides, that does bring down the x in the front. So it's no longer in the exponent. And real quick, I don't have a base here. Well, technically I have a base, it's just not there. What is the base when it's? It is 10. So what's log base 10 of 10? 1. So this is basically log of 0.75 that you'll type into your calculator. And round the 3 significant figures. What is it? 3 significant figures? One, 2, 5. Yes. 3 significant figures. You start with your first non-zero number. So there's your answer for number 3.
So would they mark off if you put negative 0.1 to the 5?
Normally that's what I would do. But I'll put a dot. So number 4. Now for number 4, ln can only be used with e. I could raise both sides to the 10th power, because what's the base here? 10. I could raise both sides to the 10th power, and then the log base 10 cancel out. Or I could write it in exponential form, which would be 10 to the 3rd power equals x, which is 10 to the 3rd power. 1,000. Then you need a calculator for that one. There we go. So you guys doing 1 and 2. Number 1.
0.8.
Okay, hold on. Yeah. Oh, yeah.
You raise it to the ln.
You raise it to that. Raise it to
Or
the
not
ln.
raise it to the ln. You put the ln under it.
Take the ln of both sides. Yes. What happens here? Yes, it cancels out. So the ln of 2. 0.8. Because it kept repeating? So
No.
No?
No.
So this was a 2 and this was a 9?
Yes.
Okay, so you rounded up. Very good. All right, then for number 2, how do I do that? E to both sides. What happens here? So I just have e to the negative 1.5, which is 223. Yeah? Cool deal. I'll do it around. They're not gonna count off if you don't do that. Laws of logarithms. These, you said these weren't in your. Okay, so these are. When you're adding and they have the same base, what are you doing to x and y? Multiplying them. Yes, when you're adding two laws that have the same base, you add you multiply x and y. When you have laws to the same base, but you're subtracting, what do you do to x and y? You divide them. And then when there's a number in front of your log, it goes to the exponent. Okay? Don't forget to remember the same reason why we take the log of both sides, so we can bring the exponent out, or the variable out of the exponent. Same type of concept here. And this can be used when you're solving logarithms, as well as expressing a super long logarithm as one smaller single logarithm, such as this here. You have log base 2 of 5 plus 1/2 log base 2 of 36 minus log base 2 of 10. And you have to write this as a single logarithm. Now be cautious, the only way that you can ever multiply your x and y or divide your x and y is if there's nothing in front of your logs. So when you ask what should you do first, take that 1/2 and move it to where? To the exponent, to the 36. So this will basically be 30 log base 2 of 36 to the 1/2.
Which is 6.
Which is 6. So you basically have log base 2 of 5 plus log base 2 of 6 minus log base 2 of 10. And now you can do the ones that are adding and subtracting. Okay, that's the only way you can do that. You gotta move everything that's in front up to the next exponent. And you just go order of operations. So left to right. So this right here is
Log base 2 of 30.
log base 2 of 30.
Divided by 10.
And so then that turns into log base 2 of 30 divided by 10, which is log base 2 of
3.
That's a lot simpler.
a lot simpler than one thing. Huh?
That's like a show problem right there.
What?
Log show problem, like show how
Exactly.
that,
That's exactly what it is.
show how that big molecular problem equals log base 2 of 3.
Here's another one. Given that A is log base 5 of x, B log base 5 of y, C log base 5 of z. We have to write this thing in terms of A, B, and C. What's something I can do here to expand this? Well, I technically got 3 exponents
I
here.
took it and broke it up by the rules, so like log 5, and then did the x first. So like, and then put the 1/2 for the, and then minus log 5 y to the second minus log 5 z to the third.
This could work. Or if you put this in parentheses,
Yes.
you should put a plus. Either way will work. Good thing about it, for those who put the parentheses with a plus, you distribute the negative over. And you get that? So the same thing. So yes, we can bring it apart,
And then you move all the exponents to the front.
move all the exponents to the front. Now that they're all separate,
And now you substitute.
now I can substitute. Log base 5 of x is a minus 2 log base 5 of y, b, minus 3 log base 5 of z. Questions? Move. There's some other ones I want you guys to do. Alright, so how can I write that in the form of y equals PA plus Q? How? So you're saying rewrite these as 32 to the power? Okay. So 27 is what? 3 to the third. And 81 is? Okay. Then from here what? What can I do? Huh? Okay, I can so expand them? Okay. How? Okay.
So for the first one, you have like a log base 3 with 3 to the third.
Okay. You combine a few steps. I'm just gonna do. Could you brought that in front?
Yeah.
Okay. So before we do that, and then what do you do from there?
Minus log base 3 to the fourth.
Okay. And if you remember from those kind of properties, when you have log base 3 of 3, what happens?
So
It cancels out. So you basically have 3a, and what about over here? Did it got the same thing?
Yeah.
You kept it with 27 to 81?
Yeah, and then I reduced them later.
Yeah. That works. What about this one? What did I do here?
You can expand it
Expand it, so we log 3 to the 1.
minus log 3 to 27.
You can actually expand it a little bit
expand
more.
that further. You can do minus log 3x squared. And then minus log 3x squared.
And the reason why it's minus is because there was a minus out here. If you kept it in parentheses, it would be a plus, and then you can distribute. Okay? So you could have kept the last two pieces in parentheses and had a plus there, but if you distribute the negative, that will give you a minus on the inside. What's log base 3 of 1?
0.
0. What's log base 3 of 27?
3.
3. And this can be written how?
2 log.
So my answer in the form of a plus b log 3x is going to be negative 3 minus 2 log base 3 of x. So using your expanding and then being able to get in the forms that they want you to write. Okay? Because it was a day. Questions? So kind of went over this already, change the base. You don't have to commit this to memory. It is in your reference book? Yes, it is. So basically, if this was my example, log base 4 of 9, I could actually do that in the calculator. I don't need a fancy scientific one. But I will type in what? Log 9 over log of 4. I would type that into my calculator. Find the two significant figures. And that gets So in this case, it will be 10. C can technically be any number base. Okay? That's something to keep in mind when you're also solving logarithmic equations, and you have to use change of base. It could be anything other than C. I mean, anything other than 10. Last few things we'll do a few solving ones, okay? I think I have. We'll do a few in each, so I can make sure I hit a few. Which one do you want to do on this page?
All.
Three? Alright, let's do 3. And if I'm gonna hit one from each slide, just to make sure I do cover at least one of them, and then if there's time at the end, I'll go back and have you do one on your own, okay? From each page. So, for number 3, is 3 to the x over 3 equals 5 to the x plus 3, okay? So all these are in the exponents. And we have to solve this. We have to solve for x. So, first thing that we can do here is what? Take the log of both sides. Because when we take the log of both sides, it brings our exponents to the front of our logs, and it gets them out of the exponents. So now we have no more exponents that we have to worry about. But I do have to still solve for x. So what can I do here to solve for x?
You can do that the same thing.
I need to get my x's to one side, and that's my logs, but everything else to the other side. Okay? So I got an x over here, x over 3, that's being multiplied to a log 3, and then I have an x plus 3 in parentheses that's being multiplied by log 5. What do you think I can do? I could divide by a log, but it's going to be kind of complicated when I have to eventually multiply by x plus 3. I probably would multiply first. I mean, it's still doable, but you just have to deal with the bigger expression to carry along the way. So this is the x log 5 plus 3 log 5.
We can multiply the one on the left side.
Well, technically they are being multiplied together. It's x over 3 log.
Well, I mean, we didn't do it out.
Well, I mean, there's not much we can do after that. Like, it's not like we can get like. I mean, it's the same thing as saying x log 3 over 3. Is that better? Correct? You want to do it that way?
No, I was just asking why we didn't do anything with that one.
It's already being multiplied together. What can I do from here? I have to get my x's to the same side. That's for sure. Everything else to the other side. Are my x's on the same side? So how about we get this x over here? Okay? Subtract it. Because remember, when we distribute, we basically were able to separate the x and 3 from being together. And so now we have log 5 plus log 3 log 5. So then we can subtract it over. And now that we have my x's on the same side in both of my terms, I can combine them. I can factor out an x. Because when I factor out an x from both of these, I have what from this first term? 1/3 log 3 minus log 5 equals 3 log 5. So that whole thing. So now that I have x, just one x, I can divide, and so I'll have 3 log 5 over 1/3 log 3 minus log 5. And I type that into my calculator to get the value of x. Let's make sure we type it in correctly. So Negative 3.88.
Are
7.
they all like equal skill level, or is?
There's certain things you gotta remember. Start one. 7. Okay. So I have this for number 7. I need to solve for x. What could I do? Careful. Divide by 35 first before you take the ln. So I have e to the negative 0.001x equals 19/7. Now remember, when you're doing things like this, in like a middle step is a decimal, okay? If you decide to start rounding here, then be very cautious about your rounding all the way through. However, I do not encourage that. Keep the most exact answer in your calculator or on your paper as long as you can. So what do I do here? Now you take the ln of both sides. And when I take the ln, this side goes away. And then to find x, all I have to do is divide. Let's type that in, make sure we can get the right answer. It's negative 9, 9, 9. Okay, that 5 rounded that 8 up. 5 rounded that 8 up. So one of these. Which one you want to do? It's probably the last one we get to do. Not necessarily the log, because we got to get in this form, so we could take the ln of everything. We can take the ln of everything, okay? The ln of 6 to the x, which technically would bring the x to the front, right? We take the ln of this inside part, okay?
So it would be x minus 1.
Now I got a question, what goes in between them? A plus equals what? Another side. 2, right? ln of 4? Here we go. Okay? Now what can we do?
Wait,
Yes.
oh wait, you took the element of 2.
2.
Oh.
Before I can factor, I have to, and before I do that, I have to, I gotta distribute. Because I have this, and I have this that needs to be distributed. And then over here, I have this. So I had to distribute first before I can get all my x's to the same side and before I factor out an x, okay? So let's get all of my x's to the same side, yes? And everything else to the other side? Yeah, there's only that x ln of 4 that's on the right side that needs to come over. And I need to just move over that ln of 2 to the other side. Give me a second. X ln of 4. And then I have to add onto the other side. So I have to get this one over here. And
Will you actually subtract it, or you just write it as
minus x. Yeah.
So
So we distribute to get each individual term, and now we have all of our x's on one side and all of our numbers on the other side. So if you factor out x now, And then
You divide.
I could divide. Could I combine that possibly? Maybe the other side? Maybe even this I could combine a little bit. Think about it. Those rules of logarithms do apply to ln.
Oh, if you need ln
6, 2, and 4 make what?
Oh.
48. So this is x times the ln of 48, because those was it laws of logarithms do apply to your ln.
Yeah,
Oh.
yeah.
Hey, man.
Yeah.
So then 6 times 2 divided by 4 is 3. That should have been a minus. And on this side, I can bring that 2 up to the exponent, and it'll be 2 times 4 squared times 2, which is 64. This looks a little nicer to divide, right? So the ln of 64 divided by the ln of 3. That's your answer. Because no, you cannot divide 64 and 3 into each other. No, you cannot divide that.
Where would I know?
Watch your signs, that's for sure. I messed up on my side.